All right, we are this thing on here using the microphone. All right, I'm assuming we're good. We are going to go ahead and just kind of walk through this study guide. I'm going to do it really quick, well, hopefully. But here we go. So, first thing, number one, we need to write the equation in slope-intercept form, which is y equals mx plus b, where m is the slope, b is the y-intercept. So this will be y equals negative 1/2 x minus 4. All right. When we graph this, we need to start by graphing our y-intercept on the y-axis. So that's going to be at negative 4. We'll put a dot. And then for our slope, this right here is negative 1/2. So you could either view it as negative 1 over 2, or you could view it as positive 1 over negative 2. But only one of them is going to have that negative sign. So I'm going to use this one, but both would work. So from my y-intercept, I'm going to go down 1, and I'm going to go right 2. So that this point right here is going to be my next crosshair. Then I'm going to go down 1, right 2 again, just like that. Okay. You do that a couple more times. Do it as many times as you want, but really you technically only need 2 points because our goal in this is to draw a line. And this is what my line is going to look like when I go all the way across, except I messed up. Let me do it this way. Oops. There we go. All right, move that a little bit, and number 1 is done. Number 2, the slope is 3, the y-intercept is 6, so my equation is going to be y equals 3x plus 6. Again, start with the y-intercept at 6. And then my slope is 3, so it'll be 3 over 1. So my slope is 3, and I'm going to make it 3 over 1. You could also go negative 3 over negative 1. Both of those ways would work because a negative divided by a negative is still positive. But I'm going to use this way here to go up 3, 1, 2, 3 over 1. Now if I tried this way again, I guess I'm going to use both ways. But if I tried this way again, I would be somewhere up here. Since I don't want to go off of the graph, I will actually now use this way. Okay, this way right here, just to show you, right? So from my y-intercept, I'm going to go down 1, 2, 3, left 1. And it should give me that same change as the other ones did. So one more time, 1, 2, 3, left 1. And that should be able to give us a line. It's not perfect, but it'll work. Should look like that. That's the first two. 3 and 4. It's asking us to find the correct slope and y-intercept and the correct equation. So the y-intercepts for both of these are going to be these points here that lie on the y-axis. Okay, it's where our lines cross the y-axis. So for 3, the slope is at 1. Yeah, let's just deal with 3. So we've got this, and then we need a rise and a run to our other crosshairs. So make dots on those crosshairs. I'm going to go up 1, right 3. So my slope, being rise over run, is going to be 1 over 3. And then, yeah, the equation, y equals mx plus b. M is slope, b is the y-intercept, so 1/3 x plus 1. All right. Number 4, we've already graphed the y-intercept. It's at 5. Slope, this time we're going down, and it gives you both of these points. So you're just going to go down and to the right. Since we went down, it's a -1. We went to the right, so it'll be a 3. So my slope on this one is actually -1/3. And then just write y equals your slope plus 5. There we go. It's interesting they have the exact same slope. Did not plan that. Oh well. Moving on. Second page. So this one we talked about a little bit in class. It's a lot of words, so read the words, okay? But it's not as difficult as it might seem. So we'll read it here. It says, the Vieira family is traveling from Philadelphia to Orlando for vacation. The equation y equals 1,000 minus 65x represents the distance in miles remaining in their trip after x hours. So this one has a lot of points, 8 points on it. 2 for the correctly labeling the axes, 3 for the correct graph, 1 for correctly interpreting the slope, and 1 for correctly interpreting the y-intercept. It's a lot going on. So the first thing we need to do is label this with our x's and y's. My y's are going to be miles. My x's are going to be hours. And I'm also going to take the equation that we're given in the problem, and I'm going to rewrite it so I have it in slope-intercept form. So my slope is always with my x, so this would be -65x plus 1,000. And this y-intercept of 1,000 is going to be where we start. Y-intercept of 1,000 is graphed here. The slope that we need to use needs to be made into a fraction. That tells me my rise and my run. My rise is actually a fall. So I'm going to go down 65 and then right 1. The thing about this is that in between this location and this location on the graph, there's 100 numbers, because 1,000 down to 900 is the difference of 100. So as long as you're close for this 65 slope, if this were your quiz, as long as you're close, it's fine. For me, 65 looks to be about, I don't know, maybe about there, and then over. And that would be my second point. So I went down 65, I went right 1. I'm going to go down 65, I think, and then right 1. I'm going to go down 65 again, maybe, and then right 1. Okay? So I hope that these are pretty lined up. They might not be, but that's okay. This problem is tough in terms of you don't know the exact locations of things. But I'd be okay with something like this. And then just connect your line. I'm a little bit off somewhere, but it's kind of close. It's close enough for me. All right? So that's what we've got. So in this problem, interpret the slope, which is the -65. For explanations, I take a lot of, I don't know, there's a lot of different ways that you could do this. So interpreting the slope, I would say, which is at -65, it's going to be, it's the change in miles left in the trip. It's decreasing, so it would mean, so there are 65 less miles in the trip each hour. That would work, okay? And there are a lot of other things that would work too. That's just what came to my head about this, right? The y-intercept is a lot easier to interpret because the y-intercept is just one location. So at that location, what's going on? It's going to be the initial or starting the initial or starting amount of miles in the trip. Okay, you could say that at 0 hours there's 1,000 miles left. That would work too. It's just after no travel has happened, or no time has passed, how many miles do we have? The last step says use the graph to determine the total distance remaining after 3 hours. If I use my graph, I'm looking at 3 hours, and I'm just going to follow that up. So I would say that looks to be maybe, I don't know, it's more than 750, I don't know, not it. 765 miles? I don't know. I mean, it's kind of up to you. It obviously wouldn't make sense because it's between these two. It wouldn't make sense to put anything more than 800 or anything less than 700. So, whatever you're kind of feeling there, that'll work. So I would say, according to mine, you could do 765. I will also say, because this is, it does say if you use the graph, right, use the graph for all that. You can also use the equation. I'll let you, I don't know, even if the directions tomorrow on that says you can't, or you have to use a graph. You can use the equation and substitute in how many miles should be left after 3 hours. So if I take negative 63 times 3, I get that number, add 1,000 to it. Oh, okay, so my graph is a little bit not super accurate. It's not too far off, but really what I should be looking for is 811 miles. So either way it'll work. I just need to see how you did it. That's all I need to see. So that's 7. We went from 5 to 8 because I can count. All right, anyway, moving on. This is another tricky one because you have to read. And it says the cost of cookies at store A are shown in the graph. So this is store A. The cost Y for cookies at store B is represented by the equation. So store B, the equation is this. Okay. So what I saw some students do earlier today, what it is it's a comparison thing. It is multiple choice, but you do have to know what you're talking about. So for store A, store A's information, we'll get there in a second. Store B is already kind of set up. Store B's equation is y equals 0.10x. And what this means here is this would be, 10 cents per cookie. Right? 10 cents per cookie. Oh my goodness gracious. Cookie. Okay, that's what that 10 means. That's the slope. It's going to be the cost per cookie because it does say in the problem X is cookies. All right? So then we just need to find store A's and compare it. Well, this also is the slope. This is both sharing y equals mx, all right? Plus b would be the y-intercept, but the y-intercept is 0 here, and obviously it's 0 there as well. So I'm just going to keep it as y equals mx, which is slope, which means we are going to find our crosshairs and our rise and our runs. I'm just going to use these two here, right, to get, if we're looking for slope, this looks like 0.5, 0.5, and then 1, 2, so this is 2. So for my slope, rise over run, the rise is 0.5, the run is 2. I'm going to use a calculator. I'm going to get that my slope is 0.25. All right, so 0.25. What is true about this? Let's see. A, it says the cookies at store A cost more. Well, is 25 cents more than 10 cents? Yep. So A should be the answer. Let's just double check. The cookies at store A cost 50 cents. Nope. They cost 25 cents. So that one's out. Cookies at store B cost $1 each. Nope. They cost 10 cents. So that's out. The cookies at store B cost more. Clearly not. 10 cents is less than 25 cents. So there we go. All right. Next one. I think we got 2 left. Yeah, we got 2 left. Okay. So this one here, we haven't had a ton of examples like this, but this one is not as hard as you might think. Okay. So we need an equation in slope-intercept form to write based off of this equation here. Well, slope can also be considered the rate of change, so the change in the y's over the change in the x. So my change in y's is plus 20 plus 20. My change in x is plus 2 plus 2, right? So I got 20 over 2, which will give me 10. So my equation is going to start y equals 10x. The problem is we need this y-intercept. Now, there's 2 different ways that you can do this. One is a little bit of like logical thinking, and the other one is some you need to be pretty good with the math to think about that. I'll show both ways, but here's the first way, and to me the most obvious way. Okay. So the thing about a y-intercept, right? The thing about this b is that it's an ordered pair where 0 is the x. Okay. And if I'm looking at this table, I see 2, 4, 6. If I back this up though, because we're adding 2 each time. So if I take it one step back here to where we are like subtracting 2, 2 minus 2 is 0. So that gives me my x. But whatever that change is, I have to do the equivalent change to my y's, and my y's are increasing by 20 each time. So again, if I go backwards that way, then instead of us doing plus 20, we're doing a minus 20. And if we start at minus 20, that gives me a 0, which all of these are ordered pairs. So this is going to end up being 0, 0. So your y-intercept is actually 0 in this particular case, just because when x is 0, what is y? Right? So there's that. That's one way to do it. The other way to do it that I think, like I said, involves a little bit more math is knowing that your x value has to be 0. So what you can do is use the equation that we have, y equals 10x plus whatever your y-intercept is. But it wants us to say, let me make sure I got this right. It wants it like this x and y, these are ordered pairs. So it wants us to substitute in a 0 for x. So what we have, actually, no, this isn't right. I don't know. Yeah, no, this is not right. I haven't done this in a minute. So let's just use this. Let's just use what we have here. Okay, this will work better. So with my x being 0, what happens is when you substitute in 0 for 10, what you're going to get is 0. So I'm just substituting at the end. I would much more recommend that method. That method's a lot easier. All right. So there's that, and we have one question left, and that's this. And you guys love these types of questions. Okay. So we need to write this thing in slope-intercept form. We need to identify the slope, the y-intercept, and then graph all this stuff. Okay. This is where we are going to solve for y on this problem. So the first thing that I will do is I'm going to add 2x to both sides. 2y comes down. 2x and 4 cannot be added because they are not like terms. So we'll do this. And then my last step is to divide by 2. To get y equals 2 divided by 2 is 1, or just x. 4 divided by 2 is 2. That's what we've got. So slope-intercept form is y equals x plus 2. My slope, because I don't have a number next to the x, is going to be a 1. And my y-intercept is that 2. That right there is most of your points. Okay? And then we need to graph this. So we can use the y-intercept of 2, positive 2. We can use the slope of 1 or 1 over 1 for a rise and a run. So rise 1, run 1. Here's your next point. Rise 1, run 1. Here's your next point. It will keep working in that general direction. So what I'm going to do is just go ahead and make my line. And then I'm going to drag it back. You guys will have rulers tomorrow to make your lines straight. So I'm not too worried about that. All right? I believe that is the last question. Okay? Look at your notes. Practice some IXL. But yeah, we got a quiz tomorrow. All right? We'll see you then.